In this video, we are starting section 1.3 on propositional equivalences. Our goals for this section are to determine if propositions are logically equivalent using truth tables, apply what are called De Morgan's laws, we'll determine when a proposition is what's called a tautology, and that refers to when a proposition is just always true, and finally, we'll apply logical equivalences to show propositions are logically equivalent. All right, so in this video, I want to focus on what logical equivalence is and how do I determine if things are logically equivalent. So let's start with the definition. So we say that two propositions are logically equivalent if they have the same truth table outputs. So when we look at their truth tables, what you get for the column of one and the column of the other should be the same. Okay, and the way we denote this is P, and we put like an equal sign with 3 of these lines, and then I put Q, and I read that as P is equivalent to Q. Okay, so I want to give one other definition. When I have the conditional P implies Q, or I can say this is if P then Q, there are these 3 other statements I want to define. So for example, the converse of this switches the order of the P and the Q. So it's if Q, then P. And right next to this, I have an example. In my example, the P is, it's Monday, and the Q is, my conclusion is, I bike to work. So the converse of that switches the Q and the P, which would be, if I bike to work, then it's Monday. The inverse keeps the P and the Q where they are, but it negates both of them. So in my example, that would be if I negate P, if not P is if it's not Monday, or I could say if it isn't Monday, if it's not Monday, then now I got to negate Q. Then I don't bike to work. And I don't bike to work. Okay, and then finally we have what's called the contrapositive. The contrapositive switches the order of the P and the Q, and it also negates both of them. So if Q, then not P. So for my example, I negate Q first. So if I don't bike to work, then I negate P. Then it's not Monday. Let me just keep Monday in my black. It's not Monday. So we've talked about the contrapositive before a little bit in our previous section, but it'll turn out that the original conditional and the contrapositive, that these are both equivalent. I'm just going to abbreviate that. It'll also turn out that the converse and the inverse, well, they are contrapositives of each other, right? Because if I take the contrapositive, I switch the order and I'm negating both of them. They're contrapositives of each other, so they are also equivalent. So now let's demonstrate that P implies Q is equivalent to its contrapositive. So why are these equivalent? So first, I'm going to show this using truth tables, using my definition. Okay, so when I do this, my building block propositions are P and Q. Okay, and now what I'm going to do is I'm going to create both of these and find their truth values. So I can have P implies Q here next to it. Before I jump to this one, I think it's going to be helpful to have not Q and not P. And once I get those, I'll be able to do the whole thing. The not Q implies not P. Okay, so I'll have my horizontal line here. After these building block ones, I'll put a big vertical line. Here was one of the major ones I wanted to see, so I'll put a big vertical line here. This last one is also a big one I wanted to see. Okay. So I wanted to see this. I'm really going to emphasize those. Those are the ones I'm trying to check. Okay, everything else is kind of like an intermediate step. So for Q, my truth values, remember I alternate true, false, and then for P, then I alternate double true, double false, right? Because there's 4 total possibilities for the truth values of P and Q, because there's 2 for each of them. Okay, and all right, so we've seen that for P implies Q, the only way this is false is if P is true and Q is false. That's the only thing that would break that rule. So that's where I have a false. Everywhere else I have true. So I'm hoping that the column for this other proposition, the contrapositive, will match that. Okay, so let's get not Q. So I'm going to negate all the things for Q. So that would turn this into a false, and then a true, and then a false, and then a true. Then I negate P, so I negate all of P's truth values. So I'll get false, false, true, true. So when is this implication going to be false? Well, I need the first part to be true and the conclusion to be false. Well, that happens in this row. First part is true, second part is false. Okay, so that's where it's false. But in all the other rows, and these rows, and these rows, that doesn't happen. So those are going to make this implication true. Okay, so now I'm going to highlight these because these truth table outputs are the same, since the truth table outputs are the same. These are equivalent. P implies Q is equivalent to the contrapositive. Not Q implies not P. Okay, so that's how I can justify that these are equivalent using this definition. Another way is a bit more informally. I could use some logic and use Venn diagrams, which is what we did in the previous section. So I want to revisit this. So when I have the statement if P implies Q, this is kind of the same thing as me saying, well, if we are in P, then we are definitely in Q. So if P happens, then Q definitely happens. So Venn diagram wise, that would be, I have a small circle for P. And if P happens, then Q definitely has to happen. So Q is a larger circle that fits P inside of it. Because we can see this. If I'm in P, if I'm in the small circle, well, then I'm definitely within the bigger circle. So this Venn diagram here matches what P implies Q is saying. Well, what would the contrapositive be saying? That would be saying if we are not in Q, then we are not in P. So does that happen in my Venn diagram? Well, it turns out yeah, because if we're not in Q, that means we're somewhere out here. If we're not in Q, we're out here. And if I'm out there, I'm definitely not in P. So that this statement, this contrapositive statement, is very much true given this diagram. Okay, so these are both, let me put this in a different color. These are both describing the same thing. These are both describing the same thing, this contrapositive and this original implication.